Right. So hi, everyone. My name is Joon Suh Choi. I am a researcher at the National AI Institute for Adult Learning and Online Education, which is a United States National Science Foundation funded institute dedicated to research on AI theory and technique that can enhance adult learning in online education. And specifically today, I am going to be talking about intelligent text, as Beck has said, which my team is currently focusing on. So before we do that, I would like to very briefly discuss why we are interested in online adult education and intelligent texts in the first place. So in the US, there's been something called the Great Resignation of 2021, which transpired after COVID. And what happened was that a lot of employees resigned en masse because they were unhappy with their wages and they felt that they were not receiving enough support in their workplace and that they felt that they did not have a chance at elevating their position within their company. And of the people who have resigned, a lot of people have chose to reskill and upskill and find a position that is higher paying and find a position that they found to be more suitable to their needs and to their talents. And of those people who switched jobs, 78% of those people said that they have took online training courses, and 64% of those people believe that online learning is essential to finding a better job. And around 2/3 of the people who found a better job said that access to employer-paid upskilling opportunities were a factor in accepting that new job. So in these cases, online training has been used as a stepping stone for these people to find better opportunities. So what this tells us is that companies should be interested in reskilling and upskilling their employees if they want to retain their employees and if they want to attract new talent. But the problem is that reskilling and upskilling and training employees is not a cheap endeavor. So for example, a report by the World Economic Forum tells us that it takes around 24,000 US dollars or around 20,000 pounds to retrain and upskill displaced workers. And another report by Training tells us that companies are spending more and more money on external training products to help them reskill and upskill their employees. And another interesting fact is that many of these learning materials are still text dependent. There are some multimodal learning materials, but many of them have a large proportion of textual materials embedded within them. So what ITEL, or Intelligent Text for Enhanced Lifelong Learning, seeks to do is to fill in these gaps. We are trying to develop a textual framework that can be deployed by different organizations without spending too much resource on it, and it should be helpful for adult learners in that it would help them reskill and upskill. So this is our team from the Language and Educational Analytics Research Lab, which is a lab within the AI-LO lab, and specifically it's a lab within Vanderbilt University. And our team spans multiple different departments across the university, including special education, psychology, linguistics, computer science, and data science. So a lot of these different people bring a lot of different talents and perspectives to the table. So this is a very much collaborative effort. So the design goals for ITEL is we want to use AI to help learners engage in interactive learning. So we are using this AI to ingest multimedia and text learning materials. I am very sorry. I think I'm just going to have to turn off my Outlook. Sorry about that. So yes, we are using AI to help learners engage in interactive learning. we are using AI to ingest existing content, and we are also to generate content, and we are also using human in the loop for content generation, meaning that this is a semi-automated process, and humans can decide to participate in this content generation process at any given time, and change any AI-generated content if they see any sort of fault in the auto-generated content. We also want to generate data for learning engineering, meaning that we want to continuously learn how adult learners are learning by collecting data. And we want to be iteratively refining our tool so that it better fits the need of the adult online learning population. We also want ITEL to support built-in analytics. We have dashboards for teachers and learners and researchers, and specifically the researcher dashboard supports data exporting that can facilitate learning research. We are also continuously collecting learner feedback to improve our tool. And another important aspect of ITEL design goal is that we want ITEL to be domain agnostic. So it works with any different type of genres of text and any different types of text. So it doesn't care what specific text it is given. It will use all of these different sort of large language models to generate content and provide an interactive learning experience. And also, last but not least, ITEL is grounded in learning science research, and I will be talking about this a bit more in the next slide. So ITEL's theoretical basis, one of the bigger pillars of ITEL's theoretical basis is the ICAP framework, which is the interactive, constructive, active, and passive framework. And what this framework tells us is that there are different hierarchical behavioral modes of engagement. So not all engagements with learning material is equal. You can be engaged passively with a material, which would mean that you are just simply storing information that you are reading. You could be engaged in an active mode of engagement in which you are storing and also actively linking and integrating all the different data that you are absorbing. And what this framework also tells us is that these modes are hierarchical. So if you are engaged in an interactive mode of reading or engagement, then this means that you are also engaged in a passive mode of engagement, active mode of engagement, and a constructive mode of engagement. So ITEL stimulates and assesses engagement across all 4 of these levels through multiple different features, and specifically through different specific learning theories, such as the self-explanation reading training framework, which I'll discuss again in a slide later on. So the reason we care about why users engage with text is that it makes sense intuitively, but also studies show that reading assessment and self-explanation, some of these interactive features that promote user engagement, improve learning gains compared to simply reading or rereading a text. So as you can see on the 3-panel comic on the right side, reading is not good enough alone. You need to be generating or creating something. You need to be actively engaged. You need to be interacting with the learning material to actually increase the strength of the memory and to gain better learning gains. So ITEL's interactive features include generative reading assessments, self-explanations, and these tasks are designed to promote purposeful, focused engagement with the text. And it's also designed to promote generation effect, which is essentially what the comic on the right is telling us, that memory is improved through construction. So, oops, sorry. Right, this part was not automated, so I had to kind of do a manual thing there. But so what exactly are the features that are included in ITEL? So ITEL, or Intelligent Text for Enhanced Lifelong Learning, as I've said, promotes interactive reading through different interactive features. And these features currently at the moment include constructed response items, which are essentially short written responses that you can write. It's what you see on the screen right now. We also have summary modules at the bottom of each page, which is what you're seeing right now. And then we have a conversational agent called ITEL AI that will help learners help elaborate any concept that is within a certain page to a user and also help them troubleshoot. And also we have a reading support agent called Strategic Thinking and Interactive Reading Support that helps users engage in a think aloud reading process, which is what you're seeing on the screen right now. And all of these features include real-time evaluation and feedback powered by different large language models. And these features have been tested through multiple different deployments. So how exactly would one go about creating an ITEL text? So ITEL text is normally, what it does is it converts an existing digital text or a plain textual material into an interactive digital text. And we currently have a content management system that helps do this, helps authors transform their static text into interactive texts. And this is based on an open source headless content management system called Strapi, which is highly customizable. And we have added a lot of plugins and modules into this content management system to make it as user-friendly as possible. It currently supports what you see as what you get, which makes a more intuitive content authoring experience for users, and the user experience is designed to guide the editing process seamlessly. And what an essential, an integral part of this content authoring system is that it has AI support and it has automatic content generation supported by AI. So what you see on the screen right now is generate question and answer pairs. So that's constructed response items automatically being generated. Key phrases from whatever source text that you provide automatically being extracted. And authors can easily choose to regenerate or modify this content as they see fit as they are authoring a specific ITEL volume. So reading and constructed response items. Reading in ITEL happens chunk by chunk. And by chunk, we mean any sort of multimedia or textual content that is under a single subheading. And as I've said in the previous slide, constructed response items are generated through generative AI with human in the loop. And each chunk has around a 1/3 chance of spawning a constructed response item that corresponds to its content. And there is at least one constructed response item that is generated per page. So users, as they are reading their text, are asked to engage with this constructive response item and receive immediate feedback as to whether they got that question right or wrong, and they can choose to skip this. But in essence, this is just-in-time feedback powered by large language models. Two different fine-tuned large language models, which are BLERT and MPNet at the moment. So what we're also currently doing, this is in a testing phase, is that when requested, ITEL AI would also explain why a user's response is incorrect, which is what you're seeing on the screen right now. So if you don't know why your response is wrong, ITEL AI would kind of elaborate and help you figure it out. And users can provide feedback on their response, on the AI's response, or about the constructed response item in general. And users can also choose to skip a constructed response item after they have failed if they, for example, believe that the AI is just incorrect and that they've input the correct answer and that they're just not getting the correct evaluation. But our current data collection shows that users choose to re-engage with these constructed response items after failing around 90% of the time. So another interactive feature in ITEL AI is the summary. So in each page, users are required to write one summary. And if they pass, that is all fine. You move on to the next page. But if you fail, you're asked to revise that failed summary at least once. Student responses are evaluated in real time with multiple large language models and natural language processing techniques. And these evaluation subcriteria include content, which is how much of the key ideas from the source text are included in the summary. Wording, which is how sophisticated your syntax and lexis is. Relevance, which is just a cosine similarity metric between the source text and your summary. Language borrowing, which essentially just measures how much did you copy directly from the source text. So this is the relevance and language borrowing are more here to serve as filters that would kind of prevent low effort summaries from entering and clogging up the large language model pipeline. And this language borrowing metric is based on trigrams, which essentially just means a sequence, whether a sequence of 3 content words are the same between the source text and the content and the summary. And also key phrase is another thing that we're looking for. How much key phrase from different chunks within the text are included in a user's summary. And then AI, after evaluating all of these different criteria, will provide feedback specific to that user's summary, depending on the content and the wording score. So the next thing, ITEL AI, as I've said, we have a conversational AI. This is based on an open source AI, so it's not ChatGPT. It's constantly being evaluated and updated with new state-of-the-art AI. Currently, we are using Orca 2, which came out November last year, which is just a really long time in AI time. We're currently evaluating some of the more recently developed models, including Llama 3 and some other generative AI, and looking to replace this with a more state-of-the-art model. And what ITEL AI does is it uses retrieval augmented generation to be aware of its context. So any information that is relevant to a user's query that is within the source text, any information in the user guide, if it's relevant to the user query to help users troubleshoot, will be included in ITEL AI's prompt, depending on the user's query. And also, if users have written any summary prior to inputting a specific query, that summary will be included as well. And so in the spirit of retrieval augmented generation, ITEL AI will collect all of these contexts that are relevant to the query and use it to generate a prompt that is specific to a query to minimize the risk of hallucination and off-topic responses, which essentially means that this is a guardrails preventing all of these different undesired phenomena that are common in generative large language models. The last feature that we are currently supporting is called strategic thinking and interactive reading support. And what this does is that after submitting a summary, if users have scored low on their content score, meaning that their summary does not contain enough of the key ideas from the source text, then users are redirected to parts of the text that they might have missed. And we use a specific algorithm to find this specific part of the chunk that the user might have missed, which relies on the similarity between the chunk and the user summary and the amount of time users spend focusing on each of the different chunks as well. And then what ITEL AI does, it asks questions informed by theories of learning to stimulate higher order thinking and reading skills development. So more specifically, what we're supporting right now, STARS 1.0, is based on Think Aloud research, which has demonstrated that more effective readers use self-explanation while reading. So they are constantly thinking to themselves and explaining to themselves as they read what they are reading. So what STARS 1.0 does is it helps readers engage in this Think Aloud process by asking specific questions. And these questions can be subcategorized into paraphrasing, elaboration, logic, prediction, and bridging. The paraphrasing, elaboration kind of speak for themselves. Prediction, it gives users a specific chunk of the text and predict what sort of information they believe will be provided next after that chunk. And bridging asks users to bridge information from different parts of the chunk and create a coherent mental representative image. And what we're developing right now is STARS 2.0, which is stimulated Think Aloud for interactive reading support. And what we want is this reading support agent to more closely follow the Think Aloud protocols. And this agent will model the Think Aloud protocol for students, and the agent will engage students in dialogue, encouraging them to think deeper for a few turns in the conversation. So what this means is that this will end in more open-ended prompts than what we're currently providing to the users, which are really specific prompts that can be subcategorized into the subcategories that I kind of discussed moments ago. Paraphrasing, elaboration, logic, prediction, and bridging. So to move on to the next part, ITEL testing. So as I've said, we have deployed ITEL to multiple different settings, and we have collected a lot of data. And I will be sharing the analyses of data collected from two separate classes. So the first data collection occurred in an introductory Python programming class at Georgia Tech. And what we did is we chose 4 chapters from the Think Python textbook and recreated them into an ITEL volume using the content management system that I showed you before. And students were offered extra credit for completing the 4 chapters. So not all students within this class were required to use this textbook. Students came to use this textbook of their own volition, and we asked them for the informed consent. And what should be noted is that all students had prior experience with Python programming, and students were also asked to complete intake and outtake surveys, and we ended up with having around 100 participants for this particular data collection. So what this data showed us is that users remained engaged with ITEL features even after they failed. So for example, after failing a constructed response items, users were free to skip that particular item and move on to the next chunk if they so desired. But they chose to re-engage with the feature around 90% of the time. And users re-engage with the text through rereading in 86% of the cases. And we defined rereading as having scrolled upwards or having scrolled back to the text more than 3% of the entire content within a page height-wise. So, and what these results showed us is that additional attempts significantly increased user scores with large effect sizes. So what we believe this kind of shows is that users chose to stay engaged with ITEL features, and they chose to re-engage with the text. And instead of doing mind-wandered rereading, they chose to do task-focused specific rereading, and this significantly increased user scores across the board. Also, these are the results from summaries. So as a reminder, student responses are evaluated in real time with multiple large language models on these different sub-criteria: content, wording, relevance, language borrowing, and key phrases. And content here is how much of the key ideas from the source text is included in the summary, and relevance is just a cosine similarity score between the embeddings of the source text and the summary. So after failing the summary, around 2/3 of the users chose to re-engage with the text through rereading. So around 1/3 of the time, users just chose to rewrite the summary without having to reread. But what this also showed is that additional attempts significantly increased users' content and relevance scores with small to medium effect sizes. So this makes sense. Rewriting a summary wouldn't necessarily dramatically increase the level of sophistication in your syntax or your wording, or the word that you chose to write in your particular summary. But if you're paying more attention, or if you're trying to retrieve more information from the source text that you have read, then you would probably be prompted to include more content, more main ideas from the source text, and your summary would end up being more relevant to the source text. So this data shows that our feature is behaving as expected, and the student's learning experience is also showing data that behaves as expected. This is a quick overview of user satisfaction. So we have found that compared to traditional texts, users found interactive text much more interesting and easier to work with, and they are particularly happy with the constructed response items. So and This is not really stringent data analysis, but you can see that level of satisfaction is somewhat high across the board. So moving on to the second data collection that we have done. This is very similar to the first data collection experience in that it was also based in Georgia Tech, and it was also collected from an introductory Python programming class. But the difference is that there were 5 subchapters, and that students' knowledge were assessed after Chapter 2 and Chapter 3 using standardized tests. So this is separate from what we kind of deployed. This standardized test was an in-class test that was administered by the instructor at Georgia Tech. And so this, again, was a participatory design, a participatory data collection in that students who wanted to use ITEL could, but if they chose not to, then they did not have to. And we ended up with having around 80 students using ITEL and around 277 students not using ITEL. But the difference between this collection and the very first collection is that we have data for the around 280 students who elected not to use the ITEL textbook as well. And we have data between the learning gains or the score for the standardized test administered after Chapter 2 and after Chapter 3. So before the use of ITEL and after the use of ITEL. So before delving into that, a very quick overview of user satisfaction. So this again shows that users were generally satisfied with constructed response items in terms of interaction, learning, relevance, and accuracy. Summaries were also pretty similar. And they showed that they were overall pretty much satisfied with the learning experience provided by ITEL, which is obviously a very good sign. So to talk a bit more about learning gains, so this is just preliminary results, but this suggests that students who used ITEL may have learned more effectively than students using a static digital text. So we conducted a Mann-Whitney U test on the delta scores. So delta scores here simply just means the post-test scores minus the pre-test scores across these different conditions. And we used a Mann-Whitney because the data was not normally distributed. And what we found is that this analysis approached significance. And the gains between pre-test and post-test for the non-ITEL group and the ITEL group was around 0.05%, meaning that users who use ITEL on average had around a 5% more learning gain compared to users who elected to not use ITEL. And this shows a small effect size. We had also conducted a linear regression analysis, and the linear regression analysis shows that more clicks and receiving a higher wording score on the first summary submission in each subchapter translated to lower delta scores, and that lower level students showed greater learning gains. So meaning that if you received a high score on your very first test, then that means that then the learning gain would be a bit lower compared to lower level students in general. So to kind of wrap this up, I'd like to discuss what we're currently working on and what we plan to work on in the future. So our newer interactive features, ITEL AI stairs and self-explanation reading training, are being tested in the learning analytics class at Cornell. So the data collection and analysis that I just shown you, you might have noticed that a lot of the features, not a lot, but 2 of the features, ITEL AI and stairs, are missing from the analysis. And this is because at the time of this deployment, these features have not been deployed yet. So these features are currently actively being tested. And we are also scheduled to conduct a more controlled test on Prolific, which is a crowdsourcing platform, and we plan on doing a remote RCT using the 3 different conditions, and meaning which is number 1, we would be deploying a digital textbook that does not have any interactive features, so it does not promote users to engage in an interactive reading mode. The second condition will be partial ITEL features without any feedback or without any ITEL AI interaction, meaning that it should be partially interactive or it should be constructive at least. And if the final condition will be a digital textbook with all of the ITEL features and STARS interaction that should promote users to engage in an interactive reading mode. We are also expanding ITEL AI's capacity to provide more individualized fine-grained feedback for CRI and summaries. And this is something that I've shown you before in the previous slides, where users could be given a more personalized, detailed feedback on their submissions for the constructive response items. And we are also producing a proof of concept for ITEL training manuals with industry partners. So what this means is that we have already deployed these ITEL in classes in Georgia Tech and Technical College System of Georgia and Cornell University. And we want to target adult learners. So this is in the right direction, but we want to specifically to target adult learners in the workforce. So we want to expand our tool to support, to be used by different employers to help their employees upscale and reskill. So we are planning to deploy over the summer at Chevron and Ford, and also at Middle Georgia State University to continue our deployment and analysis of university students as well. So this is what we're currently actively working on. So that was everything that I prepared. Thank you very much for your attention.